Okay, so last day we were just revising about computer networks and we learned about the wired media, wireless media, and basic requirements for a computer network. So what are the basic things that needed for a computer network? We just learned about that. And in the today's lessons, we can discuss further about the protocols and the topologies, protocols, as well as how these linking happen, like configuration settings. So these are the things that we have learned by now. Then here in this lesson, so we will be learning about the basic protocol. So protocol is nothing but it's a set of rules and conventions to be followed in network communication. Okay, for an example, so just think like this. I'm talking to you and you're talking to me. So we are having a conference-based class here. And so when there's a class going on, we have to negotiate the time, because the time that you are available and time that my availability is there, so we have to negotiate. Both parties must be available, right? Otherwise, if I conduct the class on the time that I'm available, and if you are unable to come to the class, if you're unable to listen to the lesson that time, then the negotiation fails. That means that communication is not a very good communication. Therefore, we need to agree on that. So the next thing is we need to agree on the lesson that we are doing. So what is the lesson that we are going to discuss? What part we are going to discuss? We need to agree on that as well. So the lesson as well as the time. A second. Right, sorry. Then, so I was telling, right, we have to discuss about the lesson, we have to discuss about the time, then we have to discuss another thing. So what language is preferred? Are we going to conduct this class in any other language or English medium? So how we are going to conduct this class, the language, and also the technology. Are we going to use Team or MS or Zoom or YouTube, or what is the media that we are going to use? Right, that also we need to discuss. So likewise, right, we need to negotiate, we need to discuss and come to some agreement, come to certain agreement before we begin, right? We need to come to an agreement before we begin the class. So that is in the basic communication, day-to-day communication, which is generally happens. Actually, in the network environment also, the devices are communicating. In the network environment, devices are communicating. So devices, these devices, routers, switches, computers, servers, client, these devices need to be agreed with certain set of rules. So that rule set is called a protocol. Okay, so please write down that protocol, a set of rules and conventions, a set of rules and conventions, so TIO and conventions to be followed in network communication is called a protocol. Examples, you can say IP, Internet Protocol, TCP, Transmission Control Protocol, and let's say HTTP hypertext transfer protocol. Like each and every service in the network, in internet, has a protocol, right? That should be followed. So this is something to be followed in the communication. Okay, IP is internet protocol. TCP is also working together with internet protocol to facilitate the basic communication layer. So it is what providing the basic communication infrastructure. Actually, TCP, IP works together. Right, let's further explore this IP, internet protocol. So in IP, the first thing that you need to know is IP has an address that is called IP address. Actually, there are two versions of IP used in the current environment. Version number 1 is IP version 4. Version number 2 is IP version 6. There are other versions, but currently we are using IP version 4 and 6. So what is IP version 4 address? IP version 4 has an address. It is a 32-bit. It has 32-bit means 10. Bit is a binary digit, no? Bit is binary digit, is 1 or 0. It is 1 or 0. So such 32 bits. 4 portions. There are 4 places. You can see first, second, third, fourth. The first octet, the second octet, the third octet, and the fourth octet. Likewise, there are octets. Octets means each 8 is taken as first 8 is taken as the first octet, the next 8 is the next octet. Likewise, dotted octet, they are separated. These numbers, bits are separated with dots, and it's a binary number. It's 10 number, and it is basically written in decimal, right? Converted to the decimal. So I hope you can remember how we converted binary to decimal. What you need to do, you have to add the positional values. Here you have 1s, 2s, 4s, 8s, 16, 32, then 64 and 128. If you add all these numbers together, the total will be 255. So adding the positional values, that generates 1 plus 2 is 3 plus 4 is 7 plus 8 is 15 plus 16 31 plus 32 is 63. That plus 64 is 127. Plus 128 is 255. That is the maximum. The minimum is 0. The maximum is 255. In between that, theoretically, any value is supported. But practically, there are restrictions. Theoretically, in between this and this, there are different values. All the values are supported in between that. And that is basically IP version 4 address. So how you can check your IP address? That is the next thing. To check your IP address, you can use, there's a command. So please write down this thing. This is very important. I'll give the note, but better you write down this because you need to remember ifconfig. Ifconfig will give your IP address details, and you can see here when I type the command, I'll be getting a report, and here this is my IP address. My IP address is 192.168.1.4. That is my IP address. So that will be given. That is how you find your private IP in your network. So let's say I'll explain what is private and what is public, right? Then if you want to find your public IP address, you have to go there, Google, and ask, what is my IP? So then it will display an IP address. This is also IP address, but this is how the internet knows you. This is the address uniquely given to recognize you in the internet. This is the address which is uniquely given to recognize you in your private network. So you in your private network, the IP recognition is called private IP. You in this internet, public recognition is called public IP. That is why there are 2 IPs, right? Actually, if you are hosting some service, if you are delivering some service, if you are providing some service, you need to buy a dedicated public IP. So that you need to purchase. You have to pay and buy a dedicated IP, right? I'll show these things. These are a bit technical. So first of all, please write down this and let me know once you're done. Right. So please check your public IP and private IP as well. So in Windows, what is the command? In Windows, the command is IPconfig, right? You have to go to the command prompt and type ipconfig. This was asked in the examination, so please be ready for these things. In Windows, it is ipconfig. IP configuration, ipconfig. That is the command. You have to go to the command prompt and type ipconfig. That will show you the IP address. Okay, then let's calculate how many unique addresses can be taken. So if there is 1 bit, there will be 2 unique addresses. No, 0 is one address and 1 is another address. Actually, you 2 unique identifiers. If there are 2 bits, 0, 0 is 1, 0, 1 is another, 1, 0 is another, and 1, 1 is another. Likewise, there are 4 addresses, 4 combinations. If there are 3, there will be 8 combinations. So if there are 32 such, there will be 2 to the power 32, which is closer to 4 billion. So this is the address space. This number of unique address can be given, but unfortunately 4 billion is not enough to cater the entire world, because the world population is far more than this. It's more than 7 billion, so these addresses will not be enough. Therefore, IP version 6 was introduced, which has 128-bit address, and it can provide this number of addresses. This is even enough to the theoretically, it is enough to the galaxy, right? The universe, maybe. Right? You can just see this is a very big figure. So you can even give the insects. You can even give IP addresses to animals, all the animals, maybe. Right? You can see, because that is a very large figure. So that is IP version 6. It is the current version of IP, but still IP version 4 used for especially private addressing. I know it's convenient, but IP address version 6 is also in the draw. So please write down that part also. And this is an example of IP address version 4, version 6. Version 4 you have already seen. Version 4 IP address you have already seen. So my IP address that I already saw is 192.168.1.4 IP version 4. And this is basically IP version INET 6 now. IP version 6. It is represented in hexadecimal. Zeros can be omitted and ignored and written like this in a shortened format. And this is an example. So you can just update that part also. No need to write in binary. So that is like when it is expanded, the big binary number, no need to write in binary, but just write the other things. So here the binary value, you can ignore that. No need to write that. But the other things, please write down. So this numbering. Then I'll explain the subnet mask concept after this. Okay, so let's learn this concept. So are you using Windows computer now or mobile phone?
It's a mobile phone, sir.
You're using a mobile phone, right? Okay, if you check in this IP address in a Windows computer, so you will get something like this. I'll show that in a screenshot, because I'm not using Windows computer now. IPconfig. When you type the IPconfig command, you will be getting something like this in Windows computer as a result. Here, this is what you are getting. You will get your IP version 4 address 192.168.52.143, then subnet mask and default gateway. So these are the things that you are normally getting here. So this is another example: IP address, subnet mask, and default gateway. So this is what you are normally getting. Let me write down that. For this calculation purpose, we just need that. Okay. So what is IPconfig command in MS-DOS? When you type this in MS-DOS, you will get 3 results. First one is your IPv4 address. So let's say 192.168.0.4 is your IP address you are getting. Then you are getting something called subnet mask. That is 192.168 sorry, that is 255.255.255.0. So that is what you get. Then default gateway, that is basically 192.168.0.1. Okay, then so what are the, this is your private IP address. It is basically in that network, it is unique, right? In that network, it is unique. So, but that does not mean this IP will not be there in anywhere in the world. So this is not unique to the entire world, but this is unique to your network. Subnet mask is actually to be masked with the IP to find the network. So let's see what is the meaning. This is the exit point to another network and centralized connected point. Typically, your router IP, router's private IP. Right? This is where all the devices are connected, and this is where you exit from your network to other public networks. So that is basically the default gateway. Okay, more interesting thing that we need to explore is subnet mask. Okay, to do that, let's do two things. Write IP this IP in binary. First of all, please write this in binary and send it to me, send it to the chat. After writing down this, so please write the IP in binary and send it to me. Then write, this is also IP. So actually this is mask, subnet mask. So in binary, right? So please write subnet mask in binary and send it to me. Then I'll tell what to do next. Okay, please do this now. This theory is very important because you are going to, right? How you are going to get the network IP is using this method, right? So actually, when you find the network IP, you can find whether the both, so the given computers are in a single network or in different networks. So that is what we can test. And also if they are in the same network, they are willing to communicate, right? Let's see. 192, you can write 11. So this is actually 128 plus 64, 128 plus 64, 128 plus 60 is 188 plus 4 is 192. Then 1, 2, 3, 4, 5, 6. Yes. Then 168, it is 128 plus 32 is basically 128 plus 32 is 160 plus 8. You can write like this. This is 168. 0 is 1, 2, 3, 4, 5, 6, 7, 8, and 4 is 0, 0, 0, 0, 0, 1, 0, 0. So this is. Then you have to write the IP of that subnet mask. That is easy. Okay, then what you need to do, you have to AND this, right? Use AND gate. AND gate operation, right? So when you do the AND gate operation, you can get this network IP. So let's AND this 1 and 1. You know, 1, 1 will be 1. So that is the AND gate. 1, 1 will be 1. But 1, 0, whatever other combination will become 0. That is the AND gate. So if both are 1 only, this here both are 1, 1. 0, both are 1, 1. 0, both are 1, 1. Otherwise 0. Then here also all are 0 because you can see here all are 0. If all are 1, but it's all are 0. Here you can see all are 0. Okay, let's write down the IP. It is 192.168. 0.0. This is actually called the network IP. Right. So if you end with subnet mask, let's say your default gateway is this one. So this is default gateway. Is this actually, if you are writing the IP address, you can write the IP address like this. Then the subnet mask is this. When you end the operation, you will get the similar. That means default gateway. This proves that default gateway and the network IP of the given network. Actually, this proves default gateway and your computer in same net, in the same, in the same network. So that is the proof. Right. Please write down the descriptive explanation how default gateway can be used. If you have any doubt, you can ask now how this can be used, how the default gateway can be used to discover the network. Then we will do a few more questions and try to understand how this works. There are two things that we need to learn. One is IP classes. The second one is classless interdomain routing, or CIDR. In IP classes, we will pre-recognize some classes, IP version class A, class B, class C, class D, class E, like we are recognizing IP classes in the IP classes. But that was a bit old method. IP classes was there to facilitate you identifying different scales of networks. Class A networks are a bit larger, class C networks are smaller. Likewise, to identify the scale of the network, this class-based IP was used, but now actually it was removed. Now we are using it is there, but mostly now we are using CIDR, classless interdomain routing. I'll explain that, but before that, please write down. Few questions. So let's try this. Okay, here. So please write down the question. There are 3 devices in a network environment. Those three devices are using the following IP address and the subnet mask. So then you have to find the network IP and the broadcast IP of each. And so if device cannot be connected using a switch, what are the possible devices? Okay, try to find out the solution. Right, what is a broadcasting IP? Broadcasting IP is basically the last IP of the particular network. So this is the first IP. No? The network IP is the very first IP that you can find. So this cannot be assigned to a device, right? Remember that this IP cannot be assigned to devices. This is to recognize the network, right? So this is regarding A, and you have to write the IP subnet mask when you end. So this is the network IP, and the last possible means when you have to put all ones without change in the network. So network is same without change in the network. What is the last possible value that you can take? That is the broadcasting IP of the particular network. Okay, for B also you can find, C also you can find. You need to do like this. Then the conclusion. So what is the conclusion? Yes, what is the conclusion? So which can connect, which cannot connect? Yes, which can connect to a similar switch and which cannot connect to the same switch. Can all 3 connect?
So the first one and the third one can be connected to a same switch.
The third one can be connected to the same network, but not the second one, right? Not the second one, because the network IP of the second one is not the same. So the first and third can be connected. Correct, exactly. So that is the thing, right? You can see first and third can be connected, and If you need to connect the second one, so if you need to connect the second one, what you need to do, you have to change the IP address of second one too, right? So that is one solution. One solution is you can change the IP address of the second one, right? Then, so it will be connected. If not, right? So there's another way. You can change the subnet mask. So see, that is also a solution. You can change the subnet mask to 255.255.0.0. Then what will happen? Then if you add this, so you can see it will belongs to the same network. That is another solution. And the solution C is basically you can use two computers and connect it to a single switch, and the third one you can connect it to a router, because this is in a different network. So you can connect different networks using a router. That is the third solution. Okay, so please explain that quickly. Okay, I'll give you, because you have to write down this, right? Okay, first of all, write down this part, I think, yeah, this part, then tell me when you're done. Right, then the class actually, so this is basically explaining you basic concept like how to obtain the broadcast IP, how to obtain the network IP. And so the table, like I said about that we will be learning class-based routing and classless routing. Actually, there are 5 classes of IP, but basically we are using 3 practically. So you can see the class A is basically the first octet value. It's ranging from 1 to 126. That is the first octet value. It's ranging from 1 to 126. It is called class A. And the remaining IP, remaining octets, like there are 3 octets. So 3 octets means 16 million computers. So these are, so that means that IP has subnet mask something like 255.0.0.0, because first set is allocated to the network, the second set is allocated to the host. Actually, this portion is also same no? Here, when you analyze this, so from actually 0 to 255, anything is belong to this network. That means how many computers, there are 8 bits, 256 computers are there, belongs to this network. All are belongs to 0 to 255. But actually we have to exclude 0 and 255. Therefore, there is actually 254 computers, because we have to exclude the first IP, which is network IP, and exclude the last IP, which is broadcast IP. Broadcast IP is used to send message to all the computers in the particular network. If you want to send message to all the computers in the particular network, then the broadcast IP is used. That is the idea. Okay, this class-based routing, I think we need to further analyze this. I'll be discussing that next day, right? So I hope you have finished writing up to here. So please understand what is host. Host means a connected computer. Network means the belonging network. Here actually you have 256 hosts theoretically, 255, 254 hosts practically. And here in the class A, you have more hosts. In the class B, average number is like 2 octets are for the networks and the 2 octets are for hosts. And the class C, only 1 here, 254. That is what we have currently discussed. Class D and E for the multicast and experimental purpose. I'll be discussing that next day, right? Okay. Bye.
Bye, sir.